Consider this. Our universe is a grand old dame, clocking in at approximately 13.8 billion years. But here's a cosmic twist. We can see objects older than the universe itself. How? Well, light from distant galaxies takes billions of years to reach us. That's right, the light we see today actually started its journey billions of years ago. So, in essence, every time we look at the stars, we are time traveling. Next up, did you know that we are all speedsters? Our home, Earth, orbits the sun at a staggering speed of nearly 67,000 miles per hour. Yet, due to the concept of relative motion, we don't feel a thing. We're all part of this cosmic carousel, spinning and whirling through space, while seemingly at peace. It's a paradox of stillness within speed, a testament to the beautiful complexities of our universe. Quite a thrill ride, isn't it? Now imagine a storm so massive it could swallow Earth thrice over. This is not a scene from a science fiction movie, but a reality in our own solar system. We're talking about Jupiter's Great Red Spot, a tempest with a legacy that dates back centuries. This colossal cyclone, with its iconic crimson hue, is so expansive that not one, not two, but three Earths could fit comfortably within its spiraling boundaries. Talk about a tempest. Let's chill things down a bit. When you think of the coldest place in the universe, you might imagine some remote, icy celestial body. But surprisingly, the coldest known spot isn't light years away. It's right here on Earth, in laboratories where scientists can achieve temperatures a few billionths of a degree above absolute zero. Absolute zero, by the way, is the point where all molecular motion ceases. So, in a way, the coolest place in the universe is closer than you think. Brr, that's chilly. Ever considered yourself as star stuff? It's not just a poetic notion, but a scientific fact. Look at your hand, your heart, even your brain. They're all made of elements like carbon, oxygen, and iron. But where did these elements come from? The answer is both fascinating and humbling. These elements were not always part of Earth. They were born in the fiery hearts of distant stars, through a process called nuclear fusion. When these stars reached the end of their lives, they exploded as supernovae, scattering these elements across the cosmos. Over billions of years, these cosmic remnants coalesced to form our planet and everything on it, including us. We are indeed made of stardust. Space, the final frontier, is not as empty as you might think. When we imagine space, we often envision an absolute vacuum, devoid of anything. But that's not entirely true. Despite its vast emptiness, space is sprinkled with about 3 atoms per cubic centimeter. That's still amazingly sparse, almost 1 trillion times less dense than the air we breathe. But it's enough to remind us that the universe, in all its grandeur, is not completely void. So space is not entirely a vacuum after all. Next, we explore the hospitable Goldilocks Zone. Imagine a region around a star where it's neither too hot nor too cold, but just right for liquid water to exist on a planet's surface. A place that could potentially host life as we know it. This is what we call the Goldilocks Zone, a crucial factor in our cosmic quest for habitable exoplanets. As we peer into the depths of the cosmos, our search for a second Earth continues. Silence is golden, but in space, it's a different story. You see, space isn't a complete void. It's filled with cosmic phenomena that, while they may not produce sound in the way we understand it, do emit radio waves and electromagnetic vibrations. These cosmic whispers, if you will, are detectable by our scientific instruments. We've heard the eerie choruses of distant pulsars, the ghostly wails of interstellar plasma, and even the low hum of the cosmic microwave background, the afterglow of the Big Bang itself. And while these sounds may not echo through the vacuum of space, they resonate within the vast orchestra of the cosmos. So, space has its own symphony. Now imagine not just one, but multiple universes. This is the concept behind the Multiverse Hypothesis. Instead of a single universe, cosmologists propose that there could be a multitude of universes, each with its own physical laws, constants, and realities. Some of these universes could be incredibly similar to our own, others vastly different. Some might contain life forms we can't even begin to comprehend. The Multiverse Hypothesis challenges our understanding of existence itself and opens up a myriad of possibilities. It's as if we've just discovered an entirely new cosmic playground. But remember, this is still purely hypothetical, as we have yet to find any empirical evidence. The cosmos just got a lot more mysterious. Finally, did you know that our universe is getting bigger every second? Yes, you heard that right. Our universe is not stationary. It's expanding. This mind-boggling fact was discovered by Edwin Hubble in the early 20th century. Hubble found that galaxies are moving away from us in every direction. It's like we're in the center of a cosmic balloon that's being blown up. This doesn't mean that the galaxies are physically moving through space. Rather, the space itself between galaxies is expanding. This revelation has revolutionized our understanding of the cosmos and led to the development of the Big Bang Theory, the prevailing cosmological model that explains the birth of our universe. It suggests that our universe started from a singularity, a point of infinite density and heat, and has been expanding ever since. And so the universe continues its endless dance.